Sweet. So, as I've written on the board, I will be lecturing on binary today. Or sorry, discussion. We will all be discussing. This is not a lecture. This is not school. So we were discussing because we're all engineers here. Yes, Eric.
So Tamir, if I want to interrupt you, if I'm a student with a question, what should I do?
Just say something. Get my attention. You don't have to sit there and raise your hand. If you raise your hand, I will immediately stop and ask you. It'll sound like we're on a roll. No, I'm kidding. So can anybody tell me what binary is? Does anybody have any idea?
It's like a method of displaying numbers?
Yes, exactly. Another way to say that is it's a number system. That's kind of the more official term. And so, do you think we have one type of number system, like in the world?
No.
Okay. No. There's a lot of different does anybody know the name of the number system that we normally use in day-to-day life? Decimals.
Yes.
Base 10. I heard someone else say base 10. Also wrote it on the board earlier. So, binary. We, as humans, think in decimal, right? You have 10 fingers, 10 toes. Computers can't think in decimal. So they think in binary, exactly. So, does anybody have any idea why computers have to think in binary? Yes.
I feel like the first computers had like switches, so they're like zeros or ones.
Exactly. And it also, that's the same reason why computers nowadays have to think in binary, but we have fancy switches called transistors. And transistors can either be on or off, or 0 or 1, or sorry, 1 or 0. Usually 1 is equivalent to on, which is also equivalent to true. So all of you working with Arduinos, I'm sure you've seen like true and false on there, and high and low, right? Yeah. So all of this comes back to binary. So to understand binary, just like Bates said before, it's just a numbering system. And the base 10 is kind of the crucial part of it. Can anybody think of what the base is of binary? Or does anybody know? Guess what it's 2. 2, exactly. So I'm going to write a decimal value here, 155. So if I write out some long, complicated equation, I have 10 to the 0 times 5 plus 10 to the 1 times 5 plus 10 to the 2 times 5, oh, not times 5, times 1. That would have been, if I put a 5 there, what number would that have been? 555, right? This also is pretty simple, but I think it's a good way to learn it to understand binary. So 10 to the 0, what is that? That's always just 1, right? 10 to, or anything to the 0 is always 1. And so 10 to the 1 is 10, 10 to the 2, 100. So another way to think about 155 is we have 1 100ths plus 5 10s plus 5 1s, like I wrote it out here. So now, if we're dealing in binary, does anybody know what one of these numbers is called in computers? Bits, right? Have you guys have heard of bits? And does anybody know what 8 bits is called? A byte. Does anybody know what half a byte or 4 bits is called? What's like a small byte? A nibble, yeah. But it's spelled with a Y. So we have a nibble here. So if we were going to change this, let's add. If we were going to want to convert this equation so that we could think in binary, what would we have to change? The 10s to 2, right? That is the base of our exponent. Hence why it's base 10. So when we're dealing in binary, everything is base 2. So we have, what is going to be the exponent of this one?
0.
0, right? And then 1, and then 2, and then 3. So, if in decimal, each digit, right? And depending on its place, it tells us like whether it's a ones or a tenths or a hundredths place or a thousandths. How many values can that digit be in decimal, in base 10?
10.
10, right? What's the lowest number?
0.
And the highest number?
9.
All right, now if we're in binary, how many numbers can we use to represent a single digit? Or a single, what's another word for digit? Not a byte, even smaller than that. A bit, yeah. So we have only ones and zeros that we can represent here to show us like how many of 2 to the zeros, how many 2 to the ones, 2 to the twos. So it's a little bit hard to think because we all think in base 10, which is also the metric system, but we don't use the metric system here. So if we were to fill in these spots, I'm going to add the multiply signs. Going from left to right, how do we do it?
1, 0, 1, 1.
Yes. Thank you guys. We have 1, 0, 1, 1. So is it kind of, do you think it's kind of weird how is, I guess, a better question to ask, going back to this binary number, which one of these bits has like the biggest effect, the biggest magnitude to our total number?
The left one.
The left one, right? And that, for that reason, is called the most significant bit, because it has the most significant effect to our number. It can represent the largest number, and then all the way to the right, we have our least significant bit.
This
So-
is Tamir, as a quick side note, I've seen at least one of their data sheets for something they're using uses references using little endian or big endian. So sometimes it's flipped around. Sometimes when you're dealing with binary, it'll be written the other way, most significant on the other side. So like if you ever are noticing that on a component that you're using, that's something to watch out for.
Yeah. That's something, but that's something you can, pretty much you just need to flip it, and you just flip this equation around. So with 4 bits here, how many decimal numbers can we represent?
16.
16, right? What's the smallest number?
0.
And what's the biggest number?
15.
15, right? And so if we made these all ones, we would have 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1. And that all equals 15, right? It seems like we're going back to elementary school for a second.
That's actually why we're here in an elementary school.
In an elementary school, yeah. So does all that make sense as far as how the binary system works? Yeah. So if we needed to represent, if we had some variable, everybody, if you're using Arduino, I'm sure you've come across variables. If we needed to represent a number like 200, how many bits would we need? Could we do it with 4? No, right? Because the biggest number we can represent is 15. So if we would wanted to represent 200, we would probably want to use a byte. So we would have 8 binary numbers, 8 bits. I used without a calculator. Does anybody know like the largest number you can represent with a byte, just off the top of their head?
55.
I'm hearing different answers. You've already gone to this discussion.
Yeah, no, that'd be.
Alright. Yeah, so that's the largest decimal value we can represent. But the total number of values that we can represent with a byte's worth of data is 256. And that's because everything starts at 0 in computers. So now that we've learned the number system, why, does anyone have any idea as to why we do it this way? I said it at the beginning of this discussion. Right, what are we thinking? Yeah, what do computers think it? Base 2, right? So, when we write 256 on, actually in Arduino, I'm gonna check that with Arduino. Jairus, that, you know the bitwise AND that we were dealing with?
Yeah,
Is that with 256 or 255?
it said it was a number between 0 and 255.
Okay, so 255. So, if we have this number 255 in base 10, that's how you like show that it's base 10. What would this look like in binary?
8 ones.
Yes, there's 8 ones. 8 ones. Okay? So, being able to convert from decimal to binary is important because pretty much everything you'll see in code is going to be in decimal. A lot of the times, the decimal value doesn't help at all with understanding because the computer is thinking in binary. So, from here, we're going to discuss about logic and logic OR case. So, a logic AND in Arduino, that was an awful ampersand, can either look like this, or we can have a double ampersand. Right? Like in English papers, you can put an ampersand for AND instead. Now, an OR is represented with
A line.
just a straight line down. 2 lines. Is it 1 or is it 2? It could be either, right? And they mean different things. So, when you have, for Arduino, when you have 1, it means bitwise. When you have 2, it means you're taking that whole number. We're just going to worry about bitwise for now because it's a little bit easier to explain. So, Jairus had a line of code. Oh wait, I think I have it backwards. I'm gonna have to double check which one's bitwise and which one is not. But the code was doing a bitwise AND. He had some variable, and he was doing a bitwise AND with 255, which, like we said before, is just a bunch of ones. So, doing it with this big of a number is kind of hard. So we're just gonna do it with 1 bit and 1 bit. And this. And we're ANDing it.
The single ones are bitwise. The single ones are bitwise.
Yeah.
Yeah. The
The single symbol is the bitwise one.
It's bitwise? Okay, so I had it right. So, I like to think of ANDs as multiplications, right? But that's just because I think in math. If we're multiplying anything by 0, what do we get? 0, right? So 1 times 0 is 0, 5 times 0 is 0, a million times 0, we're still left with 0. So that math-based explanation works really well for AND. If we have 0 and 1, what are we going to get out? 0, right? Now if we have 1 and 1, what do you think we're going to get out?
1.
We're going to get out of 1, right? And so this is called Boolean Logic. Has anybody heard the term Boolean? Right? Does anybody have like a easy explanation of what Boolean is? Yes, Lawrence.
True or false?
True or false, right? What's another way we can represent true or false?
High or low?
High or low? Can anybody think of any other ones? I guess, yeah, just yell them out.
1 and 0.
Yeah, 1 and 0, yes or no, true or false. There are many different ways to explain Boolean. So that explains AND. And so pretty much it's logic because a lot of the times there are different reasons to do it in code, but that's kind of a different discussion. So now we're going to get into ORs. ORs I think of as like plus, but it's not like decimal addition where if you add 2 plus 2 plus 3, you get 2 plus 2, 7. Right? So with binary, it's a little bit different. Still, the same rules apply. if we're ANDing anything with 0, we're going to get 0 out. If we're ORing anything with 1, we're going to get 1 out, right? So 1 or 0, we're left with 1. If we're doing 1 or 1, this is where I was talking about the decimal. This doesn't equal 2. It just equals, if we're doing, a better way to do it is that way. If we're actually doing ORs, I just think of it as pluses, but you might get confused if you're actually doing arithmetic in your code. But 1 or 1 is 1. Now what is 0 or 0?
0.
It's just 0, right? So 1, the rule of thumb always remember is 1 or anything is 1, 0 and anything is 0. Any questions about that? As far as like how it works in code, that's totally dependent on the code. But understanding this numbering system will help you understand how your code works. Yeah. Any questions?
Wait, could you go over what the difference between OR and AND is?
OR and AND. So it's Boolean logic. And so pretty much Boolean logic is kind of, it's like computer math, but the only answers are true or false, or ones or zeros. So a lot of the times, has anybody dealt with if statements or conditional statements? Yeah? So an if statement will only run, so this is the condition, and it will only run if it's true. Okay? So only run if there's a 1 in there, which is also, what's another way to say 1?
True.
True, right? If this is true, or if this is 1, or if this is yes, or if it's high, they all pretty much mean the same thing, then run your code. So a lot of the times you will have variables that you need to do some Boolean logic with, so that based on the value variable, you will either get true or false in this conditional statement. Yeah. And so sometimes you might want to use ORs, sometimes you want to use ANDs. It all depends on the case.
Could you write a conditional statement for like working in an Arduino?
Working in an Arduino.
Like if I want to change the brightness of an LED between 0 and 9.
0 and 9. So let's do something Boolean, because that's a little bit easier to do. Let's say we have some switch coming in. I'm trying to think, I'm stuck up on Jairus's example because it took some variable and it ANDed it with 255, right? Which is all ones. So if we have like 1, 0, 1, 1, let's just deal with 4 because it's shorter to write, and we do a bitwise AND with 1, 1, 1. What are we going to get out?
1, 0, 1, 1.
1, 0, 1, 1. Exactly. Right? If we change this to a 0, we're still going to get 1, 0, 0. We're going to get the same thing out. So it doesn't really seem like it's doing anything. The reason why I think it's there is because we want, it's in an if statement, so it's a conditional, it needs to be true or false. So I think it's helping it choose between the Boolean values of true and false. Yes,
Can you explain why it gives out 1, 0, 1?
So this is where the bitwise comes. Bitwise means it's doing it bit by bit. So it's taking the most significant bit of the one number and it's ANDing it with the most significant bit of your other number. And then the output is going to be the results of each equivalent bit. So if we're doing 1 and 1, we get out 1. We're doing 0 and 1, we get out 0. And if we do 0 and 1 again, we get out 0. Because like I said, 0 and anything is 0 still. So if we had, so that's bitwise. Any other questions? instructors?
Why do we use base 10 like in everyday life?
That sounds like a philosophy question.
It's really more of a
Or
history
anthropology,
question.
actually.
For
Yeah.
anthropology, my thought is
Have humans always used base 10 everywhere all the time?
No.
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 Babylonians used base 60.
Base 60?
Yeah.
Before that, we didn't have like a base system. We just used
I
Roman
guess.
numerals. It's hypothesized that if we had 12 fingers, like if humans had 12 fingers, we would have started using base 12 instead. And so we have two like digits that don't currently, like there'd be one for 10 and one for 11.
So that's how the Romans got things.
And it
We
would
follow
actually
the
make
Roman number system. We translate
it would actually
into
make
a
a
form
lot
that
of
we
like
would prefer.
basic math easier.
Oh, yeah, base
There's
12 would
more
be so much
factors
nicer.
of 12, like 1, 2, 3, 4, and 6 all are factors of 12, whereas only 1, 2, and 5 are factors of 12.
Yeah. Well, so we're getting an anthropology discussion mixed in.
So, yeah.
Does anybody want to go over a different number system that's larger than base 10?
Base 16.
Base 16. Does anybody know what that's called? Hexadecimal, right? So,
Hey, Tamir. 2 minutes.
cool. Since you guys know binary and decimal so well, this won't be too hard. So, how many, so we have a digit. How many numbers or symbols can we represent with each digit?
16.
16. So those digits are, we have 0 through 9, and then we have A through F, right? So what does F represent?
15.
No, 15.
I'm getting mixed answers again. 15, right? Because everything starts with 0. And when we normally think, we think of your first in line, you're number 1. In computers, if you're first in line, you're really number 0.
Not in MATLAB.
Not in MATLAB though, that is true.
That's the exception, not the rule, though.
Very frustrating. But you'll get to MATLAB in college when you all go study engineering. So, we have 16 digits. What do you think? Well, I'm giving away the answers. What's the base? 16, right? And what are the exponents? 0 through whatever. Through depends on how many bits you have. So, how we represent hex numbers is we throw a 0x in front, and in computers that always tells it that it's hexadecimal. And then we have our hex values. FFF. Does anybody know? So it's always, in computers, right, everything is in binary. So we always have to convert back to binary if we truly want to understand what the code is saying. So does anybody know, can anybody tell me what decimal number this is? No? So what does F represent? F represents 15, right? How do you represent 15 in binary?
5,500.
You're thinking in, I asked you what is it in binary?
Oh,
You're thinking in decimal.
Oh, binary.
Right, so how do you represent, if F represents 15, how do you represent 15 in binary? 1, 1, 1, 1, right? So what is this number in binary?
16, 1.
16, 1. Yes. And so if we had 0, 0, 0, 0, it would just be all zeros. If we had 1, 1, 1, 1, how would we represent that in binary? How do you convert from hex 1 to binary? Let's say we're talking about nibble, so 4 bits. So, what I'm getting at, so like I said before, this is 1. Pretty much what I was trying to get at is that each hex value is represented by 4 bits. Okay? or a nibble. Alright, so that's all the time we have. Thank you.